I'm Likit. Here I'm going to explain you how to find a loop in a linked list. Um, this is a famous problem asked in so many interviews. I will explain you the logic how to find a loop inside a linked list. So first of all, we're gonna create. There are two. Actually, I will go with the two cases. The first case is, suppose if I have a linked list of size determined n. Okay, suppose the first case is, if we know size n. So if you know the size n, then how to find there is a loop in linked list. Then the second condition is, if we don't know the size. The second condition is a famous condition. First I'll go with the first condition. So suppose first I need to construct a linked list. In Java there's a predefined class for linked list and all, but for the logic purpose I will be developing the core logic for linked list. So first of all, create a class static node, and the data is in data. So how the load look like here, in the sense it will be looking like this. Suppose this is an example of a linked list, and if we given a size, so actually the size of the linked list is 5. So if you have size 5, then okay, it's pretty much easier to find where the loop in there's a loop inside the linked list or not. So this is for how our node structure look like this. This is for data and this is for next pointer. So first box will be like node, first box will be like data in the node, and the next will be obviously pointed to the next node. So node next. Then using constructor I will initialize this node every time. So node, then in data, so I will be initializing every time using a constructor of the node. Then um, my node should point to next node. So node next equals to null. Basically initialized means every time it should point to null. If I implicitly give my node to point any other node, then it will be given by a method or any inside method or any directly in the main. So if we do not assign any node to next node, then it will by default it may initialize to null. So next node will be by default pointing to null if we didn't initialize the pointer next pointer to any other node. So we just created the linked list. So there's one more important point. Actually we should define a head pointer, because if there is no head for the linked list, then there is no meaning of creating a linked list and all. Head is the important point in the linked list. Then I created a node head. Then that's it. Actually I said you, and I can have a size static size of actually my linked list of size 5, so I can take it 5. That's it. Then I can insert elements in the list using inside the main method. So first thing is head equals to new node of uh, data. Then node second equals to new node of data. Then node third equal to new node of data. Then node 4 equals to new node of data. Then node 5 equals to new node of data. That's it. Just we created a linked list, but we didn't have any connection because I first itself I haven't make a clear point that suppose if we created a node, it doesn't mean that it have any connection. If we if we wantedly give a connection to that, then it will be connected to next node, or else everything here looks like, see, suppose head pointer pointing to null, then head node's next pointer is pointing to null, second node is pointing to null, third node is pointing to null, fourth node pointing to null. So there is no meaning that it's a linked list, because every node is uh, it's not connected to among themselves. So in order to connect themselves, in order to connect in between them, so head dot next, I'm making head dot next equals to pointing to second node, and then second dot next pointing to third node, then third dot next pointing to fourth node, then fourth dot next pointing to fifth node, then 5 dot next is pointing to actually I said that the linked list is of this type, uh, in the sense it's not circular linked list, it's just a loop inside the list. So this last pointer should point obviously to any of this node. So if it point to first node, then we can say that it's a circular linked list. But our problem is not circular linked list. Our problem is if there is a loop inside a linked list, then how can we find it if we have given size? So this may point to either second node, third node, fourth node. So I can give that, suppose for example fifth node is pointing to second node. So now it's a loop. So just assume, just we can print it and find whether it's in loop or not. So I will define a print method. I'll pass head so that I can use head as reference for temporary variable, and I will print elements and I'll check whether it's in loop or not. So print, I'll pass head here, and then node temporary points to head, then while temp not equals to null, then it's the case where it's in loop. Let's see whether our program is in loop or not, and means our linked list is in a loop or not, just verifying it. So print temp dot data, then every time temp should move one node, temp equal to temp dot next. So just run this and check whether our code is in loop or not. Yeah, so it was running, so it will be running so on because there's a loop, so it will be going on. So this will terminate this case. See, I said that the first case is, suppose if we given a size, then how to find there's a loop inside a list or not. So it's pretty much easier to how to find, because already we know the size. So if you check the last pointer, or suppose uh, if we check any pointer pointing to uh, suppose for this case, if we check there is a last pointer doesn't pointing to null, then we can say that there is a loop inside the linked list. So we don't need this method again, so I'll be commenting this method. So just for sake of understanding, I just printed the node list and all. So our method is find. Okay, suppose if there is a list at the end of the node, so I'll be passing node head, then every time I have already the size of node, so if I will declare one more variable here, count, in count, in count not equals to in count initially it will be 0, then while um, count equals to mm, okay. uh, okay, first thing I should mention here is I'll declare a temporary pointer node temp for traversing the list, for node temp equals to head, then while suppose we'll go into diagram. Suppose I will count every time. I'll increment the count 1 and 2 and 3 and 4 and 5. Then suppose it will point again here, so the size is exceeding. So what we say that, suppose if the size is exceeding, then we can say that well list is count is greater than size, and you will say that there is a loop inside the list. Okay, that's the logic. So if count not equals to if no count not equals to size, then we can say that we can increment the count. Okay, count plus plus, then we'll move the pointer. Okay, 10 equal 10 of next. And suppose we can say that, suppose if it's every time the count increments, then whenever it's come here, then we'll check each other. So if this at this point, whether the next is pointing to null or not. Okay, if we check that condition, if temp dot next equals to null, then we can say that no loop, else we can say that loop exists. Okay, that's our logic. Okay, I'll run this code. So it's very pretty much easier. Just you should understand what is linked list and how linked list works. So see how it my how logic works means, suppose if the list having connection. Okay, I'll explain you. See, suppose okay, this pointing to null. Suppose there exists loop here. Okay, suppose there exists a loop like this. First my temp variable lies here, then starting from start here, temp variable here lies, then again it will come here, then count will be 2, then here come here, count will be 3, then comes here, count will be 4, then again there will be ambiguity because uh, it can't go like this or like this. So that's why every time we should be having the loop at here. Loop will be a maximum at the end of the node. Okay, so loop will be at end at last of the node. Suppose if we are coming over, so my temp count will be coming here, then we'll check that if the temporary variable next is pointing to null, then we can say that there is no loop. If the temporary variable next is pointing to some other node, then we can say that there exists a loop. This is a simple logic if we have any size given. Then here comes the challenging question. Suppose if we didn't know the size, so we actually, for our sake of logic and understand, I gave 5 nodes. Suppose if I gave a list of 1000 nodes or 10,000 nodes, and my 800th node is pointing to some other 600th node, then how can you determine like this? So sorry, my 1000 node is pointing to some other, like anything else like that. So how can you determine that? So without knowing the size and all. So here in the second logic, if we don't know the size, then how can we come across this problem? So same code, no modification. So I'm gonna use here a concept called fast pointer and slow pointer concept. So fast pointer will be every time traversing two nodes, then slow pointer will be traversing every time one node. So my fast will obviously starts from head dot next, my slow will be obviously point starts from head. So just how I explain your logic how it will work, because you've seen that fast pointer every time travels 2 times, so my condition will be like this, while slow not equals to fast, because slow never meets fast, because suppose slow pointer will be starting from here and the fast pointer will be starting from here. So every time slow pointer will travel one jump, means one position, one node, then fast pointer will be coming to here, because every time fast pointer will travels. So if there is a loop, then we can say that at any time, whenever the fast point, if there is a loop, so you can say that the fast pointer will be again back to the loop. So at any time, if the fast pointer will meet a slow pointer, then we can say that this exists a loop, because in the normal list where there is no loop, there is a no case where the fast pointer meets the slow pointer, because fast pointer travels every time two nodes faster. So uh, every time we make slow pointer to move, slow equal to slow dot next, then fast equal to okay. uh, every time, whenever, if the slow equal to slow dot next, then fast equal to fast dot next, um, every time the fast pointer will travels 2 nodes. So this is the case. So we come with some problem here, like how can we determine whether okay, mm, okay, suppose if fast dot next points to null, if any case works here, fast equals to null, So for determining whether there's a, suppose there is a plain loop, plain list, such that mm, okay, okay, whenever there is a fast, okay, suppose a condition comes here, suppose if there is exists no loop at all, then for that case, so suppose if a fast dot next pointing to null or fast equals to null, then we can declare a variable boolean here, find just like a flag. So boolean flag, every time I will be setting the flag true. So it makes a flag as, suppose if fast pointer is pointing to null, okay, then we'll make the flag pointer as false. Then at the end of the loop, mm, okay, if flag, suppose if the flag doesn't come means if the flag doesn't enter into this if condition, then the flag will be obviously true and there exists a loop, so we'll print loop exists. Else loop not exist. That's it, simple logic. I'll run this code. Yeah, just simple. Okay, suppose if there exists, okay, see how it will work. Suppose if there in this diagram if there is no loop, so suppose um, if there is no loop here like this, so fast pointer will be the traveling a very faster, no? So whenever a fast or next or fast is pointing to null, then we can say that there is no loop and we'll break the loop and make the flag as false. Then outside we can print that there is no loop and all. So in this way we can find if there is loop in the linked list or not. This is pretty much easier logic. So thanks for watching.